Page 448, number 31. Find the area of a regular hexagon inscribed inside a circle of radius 12. So the situation we have here looks like this picture. I have an inscribed regular hexagon, which means all the side lengths are the same and all the angle measures are the same. And that comes out for a hexagon to be 120 degrees. So if I were to draw diagonals of the hexagon through the center, what I'm going to find is that I create 6 equilateral triangles, each of which have a side length of 12 inches. And each of these angles in each of the triangles are 60 degrees because these are equilateral triangles. So what I can do is just find the area of one triangle and then use that to multiply that by 6 to find the area of the entire hexagon. So since I know the measure of an angle and the 2 included sides, I can find the triangle area in this way. So the area of the triangle area is going to be 1/2 any of the 2 sides. So let me label this A in the center, and I'll call that B and this C. And I can choose the included angle. So it's going to be 1/2. Let's say we'll use these 2 sides, which are 1/2 of side A, side C, and then it would be the sine of angle B. So when I fill that in, it's going to be 1/2, 12 times 12 times the sine of 60 degrees. And so that comes out to be 62.35 square inches. And then I just have to find the area of the hexagon is just going to be 6 times that. And multiplying that out, I get that the area is 374.1 square inches.